Can't say for sure if I'll post this. I've been recording a lot of things lately that I don't post, but I'm excited. I've been posting about this object and the math I've been doing on it for about a year now. It's almost exactly a year ago that I started calculating this object. I'm now on page 135. And on this object, so far I've gotten to here, and I need to get to here and here. And I started here. But anyway, I'm always amazed by numbers, and I'm amazed by big numbers. And for me, a big number is a number basically bigger than a hundred or 1,000 or 1,000,000. Especially once you get into a billion, a trillion, a quadrillion, a quintillion, like you're really starting to get into some big numbers. From my standpoint, I understand there are gram numbers. I understand there are numbers way bigger than gram numbers. I understand that, like, I don't know if it's in, is it called combinatorics? Combinology? Something like that. Where there's the monster group. I remember that famous mathematician John Conway, he passed away not too long ago. Um, he'd been old for a long while. He was famous for inventing that game of life, uh, mathematical, semi game theoretical, uh, novelty of knowledge, that gem of knowledge. It's very abstract and very precise and accurate, but it's also very playful and imaginative because it mimics life in a lifeless realm. Kind of. The life it has is the life we inject into it. It's the same reason AI cannot supersede humanity as a whole. The only, though it is possible for objects to reflect the divine spark. So it's conceivable that a technology could be made that reflects like a mirror the divine spark. The divine spark shines through us towards this lens or this technological piece, however it's configured, among different fields, among different markets, among different cultures, nations, regions. Oh yeah, all I wanted to do was calculate these numbers. These ones right here. So, I'm gonna do it live to show the excitement. Isn't it exciting? Numbers? I think so. Like, this object is cool, man. Very great. Yeah, so I'm trying to get to here. And currently I'm right here. It's taken me a year. I want to get here, but right now I'm right here. It's taken me a year to get from here to here. I hear it in my ear. How long will it be? I can't see from here to here. So anyway, on this object, what these numbers are calculating is lambda u. So lambda u. So lambda is this point right here, and u is this point right here. So this point right here is u. This point right here is lambda. So what it's measuring is the distance between these 2 points. And if you look at it this way, you can see that the distance between these 2 points is 1. If every edge on this entire object, if every single edge equals the length of 1, which is how I set up the whole thing so it would be easy to calculate. And when I say easy, I mean this is what I'm trying to get to. Like, I made the sides, I made every little link 1, 1, 1, 1, 1. This whole thing is built out of ones. Even though that's not, because it's all made out of tetrahedrons, but the radius of a triangle, or I shouldn't say that. It complicates things, but making every side 1 was a deliberate choice at the very beginning, and I'm glad I made it, because I debated it for like 2.5 years, which is why it's taken me so long to make it in the first place, because I had this idea way long time ago, but like I debated for years, like, how do I set up that initial triangle, this triangle right here. It's the most important triangle of the whole thing that I made. Like, how do I set it up? How do I define it? And how do I build it from there? Well, I settled upon a very novel Euclidean starting point, and then I used three-dimensional, very basic algebra and fractions, ratios. I never rounded anything, so the ratios keep building, but we're humping back and forth between the number 1/2 and 1/2, while at the same time I'm talking about a number that's like 6 million something root 6 over 4 million something. Yet that's still a really small number, but with infinite precision. So that's kind of cool, I think. But anyway, I'm trying to calculate right now. I'm on page 135. I mean, at least that shows some level of commitment to something. Yes, I'm a failed individual. Yes, I'm damned to hell, But like, even as I'm going down, I'm going to go down to hell feet first, not head first. Because I'm going to be reaching up, man. until I get to a certain point when I have to face down, when it's like, well, I'm going there, so I gotta beat somebody up quick. Or just be eaten right away. Fine. Fine. If some hell demon eats me right away, I hope I cause it indigestion. I hope I cause that hell demon to die. If I'm diving into hell and my soul perishes, then I'm taking a demon or two with me. It's a nice way of talking about it, even though I'm very, very scared. Very scared. Very, very scared. So anyway, the excitement is in this row of numbers. If I square them all, add them up, and they equal 1, touchdown. Glorious day. I discovered something no one's ever discovered before, like a numeric anthropologist. Nobody cares about pure numbers anymore. Nobody. Everybody's all about the squiggles and the wiggles and the this and the that. But it's all convention. The closer you can get to the actual numbers and roots and, square roots, third roots, fourth roots, like roots and numbers, like calculating, and really the basics of math, like addition, subtraction, multiplication, and division, and then geometry, like better with Euclidean geometry, but also better with affine geometry, and better with like Pappas and the Wildbergian concept of was it Apollonius? The Apollonian null circle. Perhaps the most powerful concept in all of mathematics, attributed to Norman J. Wildberger of the University of New South Wales, Australia. Something like that. Let's see. Let's see about this diabolical number. It's a diabolical number. I hate it. I have to do everything by hand. And when I'm dealing with smaller numbers, like numbers below 60,000, I'll do by hand and have no problem. So like anything below 60,000 squared, I'll do it by hand and have a reasonable amount of confidence. After that, not so much. But like, so I have to use a calculator, but also I have to do it by hand. So it's like some parts I do by first at hand, and then calculator, and then I check one against the other, and I might use different ways to do it. I don't know why. It's just I have to see every little piece, But there are certain days, like, so I'm on page 135, and on each page there's like 100 calculations. So I don't know, 13,000, 14,000, or 130,000, 140,000 calculations, something like that. That's what this stupid proof is trying to prove or disprove. Because if this object is real, I really want to talk about it. And if it's not, I really want to get rid of it, because there's other real things that I know are real that are a little bit less interesting compared to this, if this is real. So at this moment, I don't know if I'm in the midst of the mystery of the truth. That's exactly what it is. I know this object is going to answer for me a question that's been on my mind for several years. If I get to this point and it proves what I think it might prove. It means that I've been living in the mystery of the truth, which means I've been living within uh, the mystery of mysteries, the mystery of reason, the mystery of Christ, the mystery of Mary, the mystery of everything. That means whatever this smoke, whatever this incense is that is swirling in my mind, if I get to hear and it's what I think it is, I feel like that's would be a confirmation that the swirl I am in is headed toward truth. But if I get here and I find that it is not what I think it is, then that means I know for sure that the ephemerality, the lightness of being that alleviates my gravity is actually just smoke, not holy smoke. So stupid. Page 135. Almost or right around the 1 year anniversary of starting this process. And I'm 1, 2, 3, 4, 5, 6. So I'm 2/3 through it, about. So 1 year equals 2/3. So that would mean if I don't become more productive, it will take me a half year. And also, I should note that as it goes on, the numbers get bigger, like crunching the numbers get bigger, even though it's still small numbers, like the fractions, because I'm calculating everything in perfection, and perfection accumulates and grows, so the numbers grow. But they're still manageable, and recently I came up with a slight innovation. Here, I'll show just a small example of the slight innovation. Just yesterday or the day before, this is my new way of multiplying large numbers by hand. It works really great because it's more like a game. Doing long multiplication and long division by hand in the way I was taught with really big, like with numbers 60,000 or below, they're fine. After that, it gets problematic in my mind because your eyes moving around like in all these places, like this weight, we carry this to here and then here to here and then back to here. It's like, whereas when you do it like this, you can just kind of fill it out like a crossword puzzle. It's just, you can move one square to the other and it all just fills itself in small little bits. So it might actually take a little more time. It certainly takes more actual work, but it's restful work. It's peaceful work, you know? Like, some work is fun and some work sucks. And like long division and long multiplication, the way I was taught it, sucks. It sucks. It's tedious work. It tires you out. It's not fun. But like, this is fun. It's more beautiful. It's more artistic. It's easier. When you're done with it, you feel better instead of feeling worse. So anyway, yeah, it's not like a great innovation, but for me, it's a great innovation because now I know I'm going to actually be able to do 10 times more twice as fast because I like it more. It's more interesting, it's more engaging, and also I like to listen to media when I work, you know? And if I'm doing long division and long, give me a second. Yeah, so this is page 114. Today I'm on page 135. Today is like June 2nd. This was back in April 9th. Long division, man. The way we were taught, it's just a mind fuck. It is a mind fuck if you're talking about big numbers, you know? And rounding is good for engineering, but for truth, no. No rounding. You are not allowed to round. You have to define everything perfectly. Which is impossible, but you have to do the best you can. And rounding is not the best you can if you're a pure mathematician. That's my opinion. Am I a pure mathematician? No. I'm a pure guy. Is that okay? Is a pure guy allowed to have an opinion about number? About meter? I think so. If you disagree with me, I wouldn't disagree with you about it. So anyway, back to reality. The number I want to get to, do. 139,832 over 531,441 close quantity x to the n squared plus quantity 280,061 square root of 3 over 4,782,969 close quantity x to the n squared plus quantity 1,873,397 square root 6 over 4,782,969 close quantity x to the n squared equals 1. Yeah. I did my math right. I did my math right. Boom, boom, boom. No. Just Yeah, you gotta prove a point, right? Prove a point. That's exactly it. Oh, I love that. I love that. I love that. Like when you gotta prove a point. Like I'm proving a point. I'm arguing a perspective. I'm whatever. But like we call it proving a point. But the real deal in real mathematics, in real geometry, is literally exactly what I just did. I'm proving a point because I just proved in real time, live, on live TV. No one's ever seen it before. I hadn't even seen it before. When I pressed record on this video, I didn't know. I had a good suspicion because I've been doing my maths right. I'll brag on that. Everything else, yeah, I'm a total piece of shit. Yeah, fine. Little whiny turd. Fine. Yeah. But I got my one, baby. Just gotta prove it. There we go. Just like I said it. Right there. Boink, boink, boink. Equals 1. Oh! Sorry. I don't get out much. And when I do, it's a problem. Papercrown. My crown made of paper.